today we are going to discuss this Leetcode medium problem, search a 2D matrix 2. So what the question says is that write an efficient algorithm that searches for a value in an n cross n matrix. This matrix has the following properties. The integers in each row are sorted in ascending from left to right, and integers in each column are sorted in ascending from top to bottom. So what this means is that take this sample matrix, right? In this sample matrix, we can see that each row is sorted within itself. How 1, 2, and 3 are all in ascending order, 4, 5, and 6 are in ascending order, 7, 8, and 9 are in ascending order. Similarly, 1, 4, 7 are in ascending order, 2, 5, 8 are in ascending order, 3, 6, 9 are in ascending order. That is, all the columns are also in ascending order. One thing important to note that this matrix could also have been like this. Let's say this is value 5, right, and this is value 7. Now the motive of this is to showcase that this value, right, the end value of any row must not necessarily be greater than the first value of the next row. So here, this is 5. This can be greater than this. This does not have to be smaller than this, right? But for simplicity, we're going to discuss this question on this matrix itself, right? So the brute force approach. So we are going to be given a target and we have to find whether this is present or not. So let's first discuss the brute force approach. So what the brute force approach says is to traverse the complete matrix and find a value. If the value is present, we return true. If the value is not present, we return false. So the brute force approach is in O of n star m time, where n is the number of rows and m is the number of columns. But is there a more efficient solution? Yes. So we have not utilized the special property of the matrix that each row and each column are sorted within themselves, right? So how to utilize that? So what I'm going to do is I'm going to start at the last value or the last column of the first row, right? Why am I doing this? I'll just tell you in a moment. Right? So here what I'm going to do, I can have 3 conditions when I take this value, right? This value can be equal to target, right? This value can be less than the target, and this value can be greater than the target. Okay? These are the 3 possibilities that I can have. So let's try for some values. Let's try for value 3. So suppose if I have to search 3 and I'm starting from here, so my first condition is satisfied and will return true, right? So let's just try searching for 2, right? So when I'm at 3 and I have to search for 2, now I know that 2 is less than 3. So what this means is that this value, the target, cannot lie in the same column, that is below this. How can we say that? Since we know that this is all in ascending order, so if we have reached a value which is greater, that means all of the next values in that column are also going to be greater than this value. So that means I have to move to the left, that this value might be present to the left. So if the current value is greater than the target, right? So if current value is greater than the target, we have to move to left. Okay. Now, what if the current value is lesser than the target? Right. So, what if the target was 7? And I'm going to discuss for target 7. So I start with 3. Now I know for sure that this value cannot lie in the same row, that is on the left side of it. Why? Because I know that this value is the biggest value so far in this row, right? So it cannot lie to the left. So the only way to go is down. So if my current value is less than the target, I forgot to change the sign here, right? So if my current value is less than the target, I move down, right? This is the entire approach for it basically. So let me just try run it for value 7 itself. Okay. So I start here at the last value of the first row, which is 3. So is 7 less than 3 or greater than 3? Of course, 7 is greater than 3, right? So what condition is this? It is this condition where target is greater than the current value. So I move down. So I come to 6. So for 6, what is the condition still? The 7 is still greater than 6. So I move more down. Now I reach 9. At 9, 7 is less than 9. Okay. So since 7 is less than 9, now this condition is not true. The condition in line number 11 is true now. So I move to the left. I've moved to 8. Right? Now 8 is still greater than 7. So that means I move again to the left. Now 7 is equal to 7. So we found our answer, and here we will return true. Right? So let me just go to the coding part now. Right? So let's just start coding. So we have taken n, which is the number of rows in the matrix. Value cannot exist. So hence we return false. What is m? M is number of columns. Right? Now this checks, the next value checks whether my columns are greater than 0 or not. So if they are equal to 0, that means again empty matrix. 0 calls. Right? So I return false. Now this value I have to check in the after this condition, after the condition of rows, because if I check it before that, matrix of 0 is a runtime error, because if matrix of 0 doesn't exist and I try to access this, now this is a runtime error, right? So I've taken two variables I and j. I is to iterate over rows, and j is to iterate over columns. So since you can see that I is 0 and j is equal to m minus 1, which is last value. So for I equal to 0 and j is equal to m minus 1, we are here, right? This is the value, right? Well, we're taking this index. Right? So let's move ahead. So now I iterate until we are in the matrix. So this while condition checks that we stay in the matrix. Stay in the matrix, right? Because if we reach outside the matrix, that means this value wouldn't exist, right? So the first condition, if matrix of I, j equal to target, so we have to return true, right? This was the first condition that we discussed, which is this condition, equal to target. Okay, right? So and next we check if matrix of I, j is greater than target. When this value is greater than target, we have to move to the left. How do we move to the left? By decrementing the column. This is exactly what I've done, as discussed over here. Right? Move to the left in line number 11 when the current value is greater than target. Right? This is the condition that I'm checking here. Similarly, when the current value is less than this, we increment the rows. Increment the row. Okay. So this was this. When the current value is less than target, we have to go down. We have to move down, right? And finally, when we exit this loop, that means the current value is not present in the matrix, so we return false. So let's just try and submit in this solution. So yes, here as you can see, we have submitted the solution, and the solution gets submitted. So, and also it is quite efficient. So that is all about it. And if you like this video, please share.